Okay, so this lab activity for Module 1 will be very similar to the skills test here in Module 1 that was entitled Graphing Simple Motion. This time the motion's not quite so simple. So it's using a similar interface, but the motion is slightly more complex. But you essentially are going to be doing much the same thing. So again, here's an introductory page you're going to start out on, and then you're going to be brought to the actual interface. Now, as is mentioned in the quiz instructions, you can pick a bunch of different variables if you want. You can change the combined mass of the car and person, make it heavier, lighter. You can increase the engine strength. You can make it a Porsche. You can make it a Corvette. What else can you make it? You can make it a Fiat if you want, or a Yugo. Most of you are not going to know what a Yugo is, but I encourage you to look that up. Wikipedia it. Anyway, you set your variables, and then you actually go ahead and just hit start, and just watch it for the first time. Just let it rip. Watch the motion of the dragster. You're not going to collect any data right now. Notice that the dragster just runs through the race for this first trial. Next time through, we're actually going to collect data. So great. Now we hit reset. Now you're ready to collect data. So notice that now when I hit start, the car pauses every once in a while, and I take data. So you might want to have a piece of scratch paper handy, and you're going to copy down the position of the car as well as the time. So notice that at time 0, your dragster's position was 0 meters. Here at 1.1 seconds, I'd have to determine what the position of my car is, and it looks like it's at the first little tick mark. So notice that each of these kind of colored bands, the red bands, those are all 10 meters, right? Because out here I can see 100 meters. There's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So therefore, each of these colored bands, like I said, is 10 meters. And of course, that 10 meters is broken up into 1, 2, 3, 4, 5 little segments. Each of these smaller dashes is worth 2 meters apiece. So if I was collecting data, I'd say, well, at 1.1 seconds, my position of my dragster was now at 2 meters. And so forth and so on. And it's going to pause every once in a while, and I'm going to collect data. Once you've collected your position and your time data, and you want to do it for the entire race, then for just the first 8 data points, you're going to create a graph. So again, you're going to go into your graphing program. If you want to, again, you can remind yourself the time needs to go on your x-axis and position needs to go on your y-axis. And then you start plotting your points. And you can have your first point be 0, 0. Okay, so at time 0, the position was 0. Remember, at time was 1.1 seconds, my position was about 2 meters, etc., etc. So you plot your first 8 points, and that's it. Then you, again, go to your graph. You're going to do a fit to it. And in this case, you're going to have to choose which type of fit best fits your data. Once you've done that, take a screen grab, upload it to your instructor. Now, you're going to answer a couple of questions about that motion. Now you're going to do the same thing, use the same graphing program, but for the next 9 data points. So after the first 8 data points, and you've graphed them, and you've done your screen grab, and you've answered your questions, now go back into that same graphing program and get rid of that first set of data, and put in your next 9 points. Again, check out the graph, do a fit, and answer some questions. And that's it. Okay, so there's 2 stages here. It's a 2-stage motion. The first 8 data points, then the second 9 data points should help you complete this lab activity.